last time we were solving this problem, right? Del squared u equals 0 and u1 theta equals f of theta. Yok pardon. Şöyle. UA diyeyim. UA bu F 0 olsun. Şunu 0 alalım. Şeyler teta'nın 0 olduğu yerlerde yani şöyle bir region var elimizde. İki tane dairesel şey. So this is radius A. This is radius B. This is our region. And the initial condition is that U is 0 here. And here U is, so B theta is F. And it's also 0 here and 0 here. This corresponds to theta is 0 and this corresponds to theta is pi. Şöyle vereyim. Şimdi bunu çözecektik. Ben biraz karıştırmıştım. Şimdi onu tekrar şey yapayım. Efendim? Ona dönmeyeceğim ya. Onu yaptık. Okey. Şimdi denklemimiz şu. So our equation is in polar coordinates is what? It was this gadget, right? U sub r plus 1 over r, u sub r plus 1 over r squared, u sub theta is equal to 0. Again, we use the method of separation of variables. So we write, we call this h, I guess, right? So we are looking for solutions of this equation where the function u can be written like this. So the variables r and theta are separated like this one in multiplicative form. And then, of course, as usual, we just take derivatives. So u sub r is just r prime times h. U sub r is r double prime h. And then u sub theta is just r times h prime. And u sub theta is r times h double prime. We plug these into the equation and we get what? We get r double prime times h plus 1 over r times r prime h plus 1 over r squared. R h double prime equals 0. And then we divide, efendim? r square ile çarpıyoruz. We multiply with r square and divide by r times h, all sides. Okay, so the whole equation. So we get just r squared r double prime plus r times r prime plus r divided by r. No, I don't have this. Okay, plus we divide by r, so we get h double prime over h equals 0. Tamam. Evet. Yok, şimdi yapmayacağız onu. Şimdi bunu diğer tarafa alacağız. We write this like this. R times r square times r double prime plus r times r prime is equal to minus h double prime over h. And then we let this guy to be r, lambda. Evet, lambda diye bırakalım. And the argument was the following. This is a function of r only. This is a function of theta only. And r and theta, right? R and theta are independent variables. By the way, let me draw the region in the r theta coordinates also. So let's say this is r and this is theta coordinates. So what is my region? Theta ranges from 0 up to pi. So 0 to pi, right? And r ranges from 0, no, a to b. So this is a and this is b. Şey yanlış yaptım. Evet. Theta. Okay. Şöyle yapayım. Bir daha çizelim. Okay. So this is r, this is theta, let's say. Theta from 0 to pi. Yeah, 0 to pi. And r is from a to b. Okay. So this is my region. Actually, it's a rectangular region, right? In the r theta plane. Nevertheless, so we have this two equations because they are functions of different variables and they are equal to each other. That's possible only if both of them are constants, and that constant actually is the common constant, and we call it lambda. So we have to determine this lambda also. From this one, we get this equation. And from the other one, we get r squared, r double prime plus r times r prime minus lambda times r equals 0. The boundary conditions gives us what? You see, we have this boundary condition. U r 0 is 0, right? So when r is 0, it is 0. Pardon, theta 0 iken 0. Burada 0, burada 0, burada 0, burada f. Right? Okay. Well, this means what? x of r times h of 0 equals 0. And if this is not 0, then of course this is 0. This is not x, this is r. I am sorry. This is 0, but this is 0 means the whole solution is 0. Therefore, this constant should be 0. And similarly, u r pi is 0 implies r of r times h of pi is 0. And that gives us h of pi is equal to 0. Okay? Well, I guess, as soon as you see these conditions and this equation, you know what the solution is, right? This is the same equation we had in heat equation for the x variable. And the only solution of this is that, so this one and this one, so this equation, h double prime plus lambda times h equals 0, together with this boundary conditions imply what? Lambda is equal to n pi over L squared, right? And actually I have lambda n. And what is the solution? Here, of course, L is just the length of this interval. So L is just pi. Therefore, this is just actually n squared. And what is the corresponding solution? Let's call it Hn theta. It is just sine n pi theta over L, which is pi. So it is just sine theta, n theta, sorry. Sine n theta. So okay. So let me rewrite what we have obtained. So this, together with the boundary conditions, this is a boundary value problem, gave us that lambda should be n squared, and for each lambda I have a solution Hn theta, and that is just sine n times theta. Okay, now let me just decorate this with also this one. And I cannot let n equal to 0, because in that case, again, I will get the 0 solution, right? So that's not meaningful. So n is just a positive integer. Now I will use this lambda and plug it in the equation we obtained for r. So for r, I have this equation minus lambda, right? Well, let me say lambda n, because I know what is this lambda. Lambda is just n squared. And for each lambda, sorry, for each n, I have a different solution, probably. So let me just also decorate it with n. Efendim? Haklısın, şurada r var. Lambda n, rn. Şöyle düzelteyim onu da. Şeyde kötü çıkıyor. Lambda n, rn equals 0. So we get r squared, rn double prime plus r times rn prime minus n squared rn equals 0. How do we solve this? We write down characteristic equation for this. Characteristic equation Karakteristik equation'da variable diye genelde ya R ya da lambda kullanıyoruz. İkisini de kullandık. O yüzden başka bir şey kullanalım. S kullanalım. Değil mi? Ne olacak? Ya da şöyle diyeyim. Rn'i değil mi? Şöyle yazabiliriz. Rn bu R'nin fonksiyonu nasıl bir şey olacak? R üzeri M diyeyim ya da mu olsun. Tamam. Lambda kullanmayalım. Değil mi? Bu mu'yu belirleyeceğiz. Bunun için de alıp bunu burada yerine koyacağım. If we plug this, we get r squared times second derivative of this, r to the power mu. Second derivative is just mu times mu minus 1, and then r to the power mu minus 2. R times derivative of this, first derivative, it is just mu times r to the power mu minus 1 minus n squared r to the power mu. Okay. Well, I have r to the power mu in r to the power mu parentheses. We have lambda squared minus lambda plus lambda minus n squared equals 0. So we get mu squared equals n squared, right? So what is mu then? So mu is just plus minus n. Okay. Of course, I have two solutions. It is plus or minus n. So what is the solution then? Rn of r is just, let's say, an r to the power n plus bn r to the power minus n. Okay. Now we have to determine these coefficients. What are these coefficients? An and bn. And how we will do this? Well, we have two more conditions, right? Two more boundary conditions. We used this one and this one, right? But I didn't use this boundary condition, this boundary condition and this boundary condition, right? We used this two, but I didn't use this two. So we will use now these two conditions to determine the coefficients. All right, so let's see. Şimdi aslında ilk önce denklemi yazalım. Solution yazalım. R theta. What is this? This is just R n of R, H n of theta. So it is just, this was sine n theta. So I have this gadget, which is an r to the power n plus bn r to the power minus n times sine n theta. Now, this is a solution of the homogeneous equation, right? Which homogeneous equation? This one. Forget these two boundary conditions. I have this equation with homogeneous boundary conditions. And what you obtained over there is just the general solution of that homogeneous equation. Since this is a solution of the homogeneous equation, any linear combination of this is also a solution. And in general, you know, we may just take any convergent series of this. So from 1 to infinity, an Rn plus Bn r to the power minus n sine n theta. Remember, when we were solving this for the disk, we had this coefficients equal to 0 because r was 0 in the disk. R could take the value 0, but on the on this annulus, r is not 0. It is always positive. Therefore, I keep this bn. All right, now let's use these conditions. U r a equals 0, right? Well, so I plug r equals a. Pardon. A yarıçap. Efendim? Evet. Aslında neyse. Şöyle diyeyim. 0 u a theta, right? So when I plug that, I get a n a to the power n plus b n a to the power minus n and sine n theta. And the whole thing is equal to 0. This implies what? Well, I can just try to find this coefficient. What is this coefficient? It is just integral of 0 times this function, right? From 0 to L, whatever. But that would give me just, this coefficient is 0. Değil mi? Fourier teorisinden, from the Fourier theory, we know that this coefficient must be 0 because if you try to obtain this thing, evaluate this coefficient, compute this coefficient, you use integral, and the integrand is just 0 times this gadget, which is 0. So this thing is 0 means what? For all n, of course. So an a to the power n plus bn a to the power minus n is 0. So this means what? This means, for example, here, of course, a is a positive number. So bn is what? Bn is just minus an and n to the power 2n, right? Yani bunu diğer tarafa atıp a üzeri n'le çarparsanız bunu elde edeceksiniz. So let me just plug it here. Therefore, an plus bn pardon şöyle diyeyim. So what is okay, let me just use this information to rewrite ur theta. Ur theta is then n from 1 to infinity. Bn is just this gadget. So it is what? An r to the power n plus, well, that becomes minus an an a to the power 2n r to the power minus n and sine n theta. Okay. Bunu daha güzel yazabiliriz herhalde. A üzeri n'i dışarı alırsak şöyle yazayım. Let me take an outside and a to the power, efendim? Yanlış mı ya? A üzeri n'i de dışarı alayım. A üzeri n'i dışarı alırsak burada ne kalacak? R üzeri Ee, aa, şöyle R bölü A'nın n'inci kuvveti eksi R bölü A'nın eksi n'inci kuvveti gibi bir şey kalacak. Doğru mu yaptım? A üzerine aldım. Tamam, doğru. Şimdi diğer boundary condition, bunu yazmak zorunda değilsiniz. Böyle hani ben böyle simetrik bir şey olsun diye yazdım. So let me erase this part. Okay. Now to compute the coefficient an, I use the last boundary condition. F of theta is u b theta. Well, so for r, I write b. So what we get, n from 1 to infinity, an a to the power n, and then r is equal to b. So b over a to the power n minus b over a to the power minus n, and we have sine n theta. Well, then I have what? This whole thing, right, is equal to what? From the Fourier series, 2 bölü L mi olacaktı, 1 bölü L mi olacaktı? 2 bölü 2 bölü L, sıfırdan L'ye. Tamam. So 2 over L, 0 to L, f of theta sine n pi theta over L d theta. Here, of course, L is just pi because theta is ranging from 0 to pi. So this is equal to what? 0 to 2 over pi, 0 to pi, f of theta sine n pi. Evet, bu şey f yerine mesela bir şey verseydik, bir değer verseydik, ne yapalım? Mesela bir örnek yapalım. Example, f of theta şey olsun, sin 3 theta olsun. O zaman ne olurdu? So this is sin 3 theta, let's say. So this is just 0 unless so this is 2 over pi times 0 if n is not 3, and if it is 3 then it is what? Ne çıkar? Sinüs karenin integrali sinüs kare şurada yapalım mı? Efendim? İşte onu hatırlamadığım için. Tamam. Sana inanıyorum. Efendim? Efendim? Ha evet, 1 çıkması lazım. Okey. Tamam. Ee, evet. Yani ne elde etmiş olduk? So let's write down the solution. Şunu sileyim artık. So we have only one term, right? We have only one term. U r theta. So we have only the term for n equals 3. So it is just a3 a cubed, right? And then b over a cubed minus a, no, b over a to the power minus 3, and then sine 3 theta. Okay. A3 is actually 1. Değil mi? Yok. A3 1 değil. Özür dilerim. Ha yok. Bu yanlış yaptık. Bütün ifade 1'e eşit. Okay. Yeah. Yeah. We computed that this whole quantity is just 1. So it is just sine 3 theta. O kadar uğraşıp bunu bulduk. Tamam mı? Sorusu olan var mı? Any questions so far? Efendim? İnandık diyorsunuz. Efendim? Çünkü şeyden şunun tamamı e, ya 0 ya da 1. Ne eşittir 3'te 1. Dolayısıyla bu katsayı 1 yani. Ne eşittir 3 için. Tamam mı? So this whole coefficient is equal to 1. That's why I have 1 times sine 3 theta. And for n different than 3, it is just 0. Tabii yani bu katsayı bu işte. Sinüsün katsayısı. So this coefficient is just equal to this gadget. Ha orada yerine koymadık. Niye? Ha şurada unuttuk çünkü. Yok yok, özür dilerim. Okey okey. Ha bir de r küp var o zaman. Yok. B yerine r yazacağız. So we have only r here. R. I'm sorry. Sınavda bunu yaptınız mı? İşte 0 alırsınız. Okay. So here in the solution you have R here, not B. Aynı şey olmayacak mı? Ha. O zaman dur bir saniye. Evet, bende de biraz farklı çıkmış. Dur bakayım. Nerede hata yaptık? Bir saniye. So okay. I'm sorry. Yeah, we have A3. What is A3? A3 is just yeah, 1 over that gadget. Yes, 1 over A cubed, right? A cubed b over a cubed minus b over a minus 3. Okay. So bu da nedir? 1 over buradan b cubed, buradan da b küp, pardon, a üzeri 6 bölü b küp, a to the power 6 over b to the power 3. All right. So the solution u r theta is just the infinite series. An is just this gadget. Well, A3 is this gadget. So it is just A3, A to the power 3, and then R over A cubed minus R over A minus cubed, right? Minus 3, and then sine 3 theta. Okay. Yani işte A3'yi yerine koyarsak A küple çarpıyoruz. Ya da A küple burada çarpsak şimdi şunu yazalım. 1 bölü so b cubed minus a to the power 6 over b cubed, and then here we have r cubed minus artı. Okay. Yani belki daha sadeleşebilir ama kalsın. Sorun değil. Whatever. Okay. Peki tamam. Bu böyle olsun. Şimdi more Laplace equation. Öbür tarafı sileyim. Okay. Bunu yazdım ama öbür tarafa bakıyormuş şey. Okay. U r theta is this one. Peki. Şimdi böyle denklemlere bakalım. The Dirichlet problem, boundary value problem. Okay. So this kind of equation in Cartesian coordinates. So our Laplace equation is this: u y equals 0. Here x is between 0 and a, y is between 0 and b, and I may have 4 boundary conditions for each one. Here x is between 0 and a, y and b. Yani, so we have this equation. Okay. Here we have the equation, Laplace equation. So it's a harmonic equation, a harmonic function. And here it is f1. Here it is f2. Here it is g1, g2. Neleri ters yazdım? Sıfırdan a'ya. Tamam. Tamam değil mi? Nasıl çözeceğiz? Well, solving the general equation like this, if all the boundary conditions are non-homogeneous, it might be difficult because if you don't have zero boundary conditions, then you don't have shortcuts. So the idea is that you break this into four equations or problems. Okay, idea to break this problem into four problems. Şöyle, işte ilki şu olacak. Her seferinde bir tane boundary condition alacağım, diğerlerini sıfır alacağım. So we have the same equation, and here I have, this is f1, but the other condition is 0, and here the conditions are again 0. No, a, y, right? This is one equation, and then I have, so from this I will get a solution, let's call it u1. From this equation, this time I will let this guy to be 0, this guy to be f2, and again homogeneous conditions here. From this I will get u2, and so on, and then u3 and u4. And what will be the solution? Solution u of our original problem. You see, if you just add all these four conditions, it will satisfy this equation and plus all the boundary conditions. So our solution will be just u1, u2, u3, and u4. So you just solve the same equation 4 times with different boundary conditions. Let me just do one of them. I mean, it is not meaningless, to solve this equation 4 times. Ama aslında tabii ki, yani çözümlerin hepsi birbirine benzeyecek. Ama hani işte ne bileyim, her birinde Fourier katsayılarını hesaplamak gerekebilir. Yani o kadar da basit olmayabilir. Let me just do one example. Bunu çevirmemişim. So to solve an equation like this, boundary value problem, Dirichlet boundary problem, where we have 4 different boundary conditions, they can be all non-trivial, so non-homogeneous. To solve this, we just break the problem into 4 problems. In each of them, there will be only one non-homogeneous condition, and the other 3 are homogeneous. We solve each of them, okay? We call the solutions U1, U2, U3, and U4. Okay, each time we just pick one of them, and it will be non-zero, the others will be 0. And the solution of our problem, of this problem, original problem, will be just the sum of these solutions. Now let me just solve one example. Şöyle yapalım. Bir tane example yapayım. Sor. Ha, orada o ama muhtemelen ya çalışmıyor burada ya da problemi bir orijinal diğer hale getiriyor. Yani orada öyle bir şey yaptığımızda initial condition değişiyordu. Burada initial condition değişmeyecek. Y'li terimlere getirecek. Hani birinden kurtulayım derken öbürü olacak yine. Hani herhalde muhtemelen işe yaramayacak o yani. Yani kolaylık sağlamayacak diyeyim. Okay, now let's consider only one of them. So I keep I take this one non-zero and this one 0. Bu arada zamanımız bitmiş. Okay, let me just write down the problem, but I'll solve it in the second hour. So again, we have this rectangular region, X, Y. This is B, this is A. So I have F here and 0 condition here, 0 here, 0 here. And here we have the Laplace equation. And let's solve this in the second hour. Okay.